Looking down through the tiers of this server rack, consider the sheer volume of modern data generation. Type a single instruction into a prompt today, and within seconds, the machine spits out hundreds of lines of complex code. Because the AI responds with such speed and apparent confidence, it suggests that the human element of coding has become redundant. This creates the impression that learning to program is a relic of a slower era. But if you look closely at these instant outputs, you find a severe friction point. Surface-level perfection frequently hides deep structural flaws that no machine is programmed to catch. Confusing raw speed with autonomous accuracy creates a dangerous vulnerability for anyone trying to build functional software. The root of this vulnerability is a concept called an AI hallucination. This occurs when a machine confidently presents information that is logically incorrect or completely fabricated. To a beginner, these side-by-side code blocks look perfectly functional, but buried in the right block is a structural flaw, glowing in red. A non-programmer is blind to this error, so this single unverified flaw easily spreads to the rest of the system architecture. Without the ability to read and repair code, you are at the mercy of a black box, unable to navigate your way out when the machine inevitably makes a mistake. The rise of AI hasn't erased the human programmer. Instead, it has elevated the job description. We have to shift from acting as manual typists to functioning as a human compass. In a landscape of broken digital pathways, we provide the essential human oversight needed to point the system in the correct direction. Rather than writing every single line of a program from scratch, the modern workflow requires us to analyze machine-generated results, identify the hallucinations, and discover the hidden errors. To succeed in this auditing role, a professional needs a highly developed capacity for logical thinking and system-level analysis. Human logical oversight is the only barrier between a functional system and a series of compounding, undetected failures. The best environment for a beginner to build that strict logical framework is the programming language Python. Python strips away dense syntax noise, the confusing brackets and semicolons of older languages, leaving clean, interlocking geometric shapes, representing pure problem-solving mechanics. By manipulating these clean pathways, Python acts as a mental gym, teaching you the strict rules of digital architecture. Once you internalize these logical rules, it becomes instantly obvious when an artificial intelligence attempts to break or bypass them. Learning Python is rarely about memorizing the vocabulary of a language. It builds the mental discipline required to map out and defend complex digital structures. Mastering programming logic moves a user from the passenger seat to the role of technical director. Look at this flowchart to see the requirements of a modern data scientist or software engineer. Raw, chaotic data streams generated by the machine must pass through a strict verification checkpoint where human logic strips the anomalies away. This specific checkpoint enables high-level tasks, parsing massive datasets securely, guaranteeing correct execution of software paths, and verifying system health before deployment. The technology industry does not pay for the raw, unverified output of a prompt. They pay exclusively for this human verification layer. True professional value lies in correcting the machine rather than trying to outpace it. A user relying on tools remains vulnerable to their flaws, but a programmer commands the broader structure, dictating exactly how those tools operate. Start your journey by learning Python, so you can command artificial intelligence rather than serving it. These programming languages are the analytical filters we use to keep automated systems honest.